Hey everyone, in this video we're going to go through question 7 from the term 1 holiday homework. So we've got this polynomial, so p of x equals blah blah blah, and you've also got this q of x in here, all right, which kind of adds an element of difficulty, or maybe you're just like, what? Okay, so q of x is just a polynomial. All right, we don't know what it is, what type it is. Okay, so it's just sitting there, and you'll see later on how it appears in the final answer. All right, so we've got a little bit of information. So when p of x is divided by x plus 2, the remainder is 6. So we're going to look at that first bit of information. So let's write that down. So p of x, when it's divided by x plus 2, the remainder is 6. So basically, p of negative 2 is equal to 6. All right, so that's that little bit of information. Now, we can use the second bit of information. Let's do it in a different colour because we're going to be doing a few things here. All right, and then when p of x is divided by x minus 4, the remainder is 12. So let's write that in pink. All right, so basically p of 4 is equal to 12. All right, so we want to know what the remainder is when p of x is, let's do it in a different colour. Oh, that's not going to work too well. When p of x is divided by x plus 2, x minus 4. All right, so a bit complicated, and even trying to do the process of elimination is quite difficult. Okay, so let's just have a look first of all at so if you have a look at your p of x, you've got an a and a b. All right, so we've got an a here and a b. So let's substitute in p of negative 2, and then we'll do p of 4 and see if we can get our values of a and b. So I might need to make this a little bit smaller just so we can see everything at the same time. All right, and let's change the colour to black. Okay, so first of all, I'm going to do p of negative 2. All right, and I've just used the remainder theorem here. I'm not going to go into it in too much detail because you should know about it, but if you're a bit unsure, then make sure you review that. Okay, so p of negative 2. So I'm basically just substituting in negative 2 everywhere I see x. So the first one is going to be negative 2 plus 2, x minus 4 times q of x plus a times, oops, let me just change that. That should have been a negative 2 plus a times x. So x is negative 2 plus 2 and then plus b. All right, so you'll notice that negative 2 plus 2, that's 0. So basically 0 is going to be multiplying this bracket and your q. So that all becomes 0. So it basically disappears. And then we've got the negative 2 plus 2 here again. So that's 0. So that goes. And we're effectively just left with b. So we know that when p of x is divided by x plus 2, your remainder is 6. So b is equal to 6. Now my b and my 6 kind of look the same, so let's change that to make it look more like a 6. Didn't really work. All right, and we do the same thing with 4. And you will notice, without doing too much work, let me just put it up here. When I put a 4 here, that's going to equal 0. Okay, so I'm just going to get rid of that. Okay, so this first term has gone because 4 minus 4 is 0. And then we've got a times 4 plus 2. And then remember, b is equal to 6, so it's just plus 6. All right, so we've got 6a plus 6, and the remainder is 12. So I'm going to put 12 over here. So that means a is equal to 1. All right, so that's our second value. All right, so we can just substitute them back into p of x. I'm running out of room here. Let's see if I can do it a little bit over here because we don't really need, it's going to be a long expression. Let's change the colour. Let's do blue. Let's do this blue. Okay, I just don't want to go on to the next page. All right, so P of X is equal to, so I'm just going to copy just what we've got up the top here. All right, our expression for P of X, but I'm going to put A and B in there. All right, so we've got X plus 2, X minus 4 times Q of X, and I'm going to run out of room. Oh, this is so frustrating. I might have to go on to the next page. All right, just bear with me. Oops. You'll notice I put in A, but we know A is 1, so I can just get rid of that. Okay, so there's our expression now that we know that A is 1. So you can put a 1 there, but it's 1 time, so we don't tend to do that. I'm just going to have leave it with a big gap. And B is 6. All right, so we want to know what the remainder is when P of X is divided by X plus 2 times X minus 4. All right, so what we can do is say, all right, let's divide it by X plus 2, X minus 4. So that means that everything is divided by X plus 2, whoops, times X minus 4. And what we've got here is effectively X plus 8. All right, so we'll, if I got rid of those brackets, it would be X plus 8, so X plus 2, X minus 4. Now, the reason why I can separate them into two separate fractions is because I've got a plus sign here. All right, and that's going to help me actually say, oh, well, that's going to cancel out with that, and that's going to cancel out with that. So then I'm just left with Q of X. And on this side, I've got on my numerator X plus 8. So effectively that is our remainder. So we've got Q of X, which we don't know, but it's some polynomial, okay, that's being divided into P of X, another polynomial. And then our remainder is X plus 8. So if you think of it in simple terms, like if you were to do a division, so let's say if I did 13 divided by 2, I know that is 6, remainder 1. Okay, so your remainder is 1, but if we were to write that as a number, it would be 6.5. Okay, so in this case, the 1 is our remainder. So, sorry, in the 6.5 example, the 1 is your remainder. In this question, which is a lot more complicated, wouldn't it be nice if your methods question was just 13 divided by 2? Your remainder is X plus 8. So your answer to this one is E. All right, quite a tricky question and one that I think you couldn't even confidently guess. All right, bye.